I don't want my videos to make money. Why would I want to do that? Yeah. Okay. What was it again? Volume? Janmar? Volume. Okay. Let's do this, guys. So I will do the volume for this. And surface area, you're fine, Janmar? Surface area. Anybody wants surface area on this one? No? You just got it? Okay. All right, so I'll do the volume. And I always tell myself what to do. So I'll do volume of pyramid. Have some sort of way to distinguish. Sometimes students just go volume plus volume. It's like, okay, great. But I would like to know what's what, right? Volume of box. Volume of the pyramid. What is the formula that I gave you? I have to make sure. Sometimes I mix up letters. So I think for a pyramid, if I look at this, it's A squared times height divided by 3 plus volume of the box is just length times width times height. And so A, for me, this is A, right? Because if you project it up, it's also 16 here for this base, right? So it'd be 16 squared in a sense times the height. So here, yeah, now I get it why you asked for volume. You have to figure out the height of this thing. Okay, you have to figure out the height. I give you, this is the slant. You have to figure out the actual height going straight down the middle. So I would encourage you to just make a little triangle, right? Literally this cutout here, where the slant becomes this. What is this going to be down here? It's 16 from end to end, right? This goes down to the middle, so it'll be 8. And then this is my height. It's not hypotenuse. H stands for height, okay? So if you want one of the legs, this is the hypotenuse, these are the legs. If you want one of the legs, you need to take the square root of the hypotenuse squared minus the other leg squared. So that would be square, this is 100 minus 64, 36. Oh, nice. A nice round number. I can live with that. So, right, that's something that you need to do. Is that right? It's good? Yeah, 64, yeah. Okay, so then you have the height, you bring that in here, okay? So that is your height plus length times width. This is also 16 times height. This is also 16. How do I know everything is 16? Because of this word cube. Cube is a rectangular box where all sides measure the same. All dimensions are the same. So I can actually just go 16 to the power of 3, correct? Because it's 16 times 16 times 16. That's 16 to the power of 3. Lots of 16s, right? So 16 squared times 6, that's 1536. Plus 16 to the power of 3, that's 4096. Oh, I see where this is maybe going. I made a mistake on my key, maybe. That's why you're asking me for it. Is that why, Gemma? Was your answer not matching my answer? But oh, okay. But according to this, mine is wrong. My answer is wrong. So what happened? Oh, I know what happened. What happened? You're the teacher. Where would you go -1? I see it, Chandra. Yeah. Yeah, I forgot to divide by 3. And I'm honest, I did not do it on purpose, okay? So I forgot to do that. So this goes back to the drawing board here. That's why I love this calculator. Copy, paste, divided by 3. This is technically 512, right? So it's 512 plus 4096. 4608. Now we're in business, right? Now it matches. So cubic centimeters, because we're in volume land, right? Does that make sense, Jamar? Yeah. Mm-hmm. For the surface area, I would just, like, okay, total surface area would be surface area of the box plus, I will just go lateral surface area of the pyramid, meaning when I'm looking at the pyramid, I'm only going to add the sides, right? When it comes to the box, I'm going to first pretend like everything is part of it, and then I subtract a square. Okay, like, so surface area of the box, lateral surface area of the pyramid, and then take away one because when we calculated the box, we've included this, right? So you either do it this way where you subtract, or you right away, because what's the surface area of the box? Maybe I should give you the surface area of a cube on our study sheet. The surface area of a cube is actually, surface area of the cube is 6 times a squared. Because basically if you go 16 times 16, if you figure out this, you just multiply that by 6. 1, 2, right, top and bottom, and then 4 all around. So this is the shortcut for a cube. And if you missed it, 2 times length times width plus 2 times width times height, it's the same thing. You're going to get the same answer. So surface area of the box. So basically, I think you're going to understand, instead of 6a squared, what am I going to use here? 5a squared, right? Plus lateral surface area of a pyramid, it's 2. What did I give you? AS or BS? Got to be careful with letters here. What a bunch of BS, right? So 5, 16 squared plus 2 times 16 times slant. Slant is 10. You do it like that. Does that make sense? Yeah. No, that's good. So you went 4 triangles because there's 4 triangles, yeah? Yeah. Yeah. Mm-hmm. Twice because of the top and bottom. Can I say, okay, I'm going to be very carefully with my wording. If you're going to do surface area of the pyramid and surface area of the box, right? Add them. Then you need to subtract 2 squares actually. You need to subtract the square that you included when you did your pyramid, and you need to subtract 1 square when you did the box. Exactly, because I did lateral surface area of the pyramid, I don't even include it. Like I'm actually already subtracting here, right? So I wish I could give you just like a silver bullet that works every time. You just have to make sure what you do, you keep track of what are you adding, and then you subtract accordingly, okay? Yeah. Okay. Sounds good. All right. We're good? Any other one? Yeah. I'm thinking 23, the lunchbox. I didn't assign that one, did I? So that's where I'm going after this, but is there a different one, Philbert? Number 4? Okay, let's do that one. And then we'll do the lunchbox. That'll be like my lesson because now we're halving things. We're cutting things up, okay? The storage bin is shaped as the figure, the radius. Please read carefully. Is it radius? Is it diameter? What are they giving me, okay? The radius of the cylindrical top is 7 feet, so you know that from the center to the side is 7. The overall height of the bin is 26 feet. What does that mean overall? It means the whole thing from top to bottom. If you could do this, you would go right in the center of this thing, right, from top to bottom, but I'm going to do it off to the side. So it's 26 feet from top to bottom. And the altitude, several students ask me, what is altitude? Altitude is height. Okay, a plane flies at an altitude of 10,000 feet, right? So that's the height. The conical section is 12 feet, okay? So that means that it's 12 from here to here, it's 12, right? So this is 12, and from top to bottom is 26. So a lot of stuff going on there. Let's use a red pen for what remains. If this is 12, we go 26 minus 12. What is that? 14, right? So that's something that I would put down there. It's not drawn to scale, obviously, but it doesn't matter. Are we good so far, Filbert? Yeah. Which part, can you tell me which part you want the whole thing? The volume and surface area? I can do both, I just want to know. Do both? Okay. Okay. I wouldn't mind a cone right about now. Later. Okay. So, what do we have? We have the 12 here. Because this 12, you got to be able to translate stuff, okay? 12 is here. This is 7. This is the slant. I don't know what it is yet. But I'm probably going to need that because I need surface area. Okay, here we go. What are we going to do first? I'm going to do volume first because I have the height of both. So let's just go ahead and volume. Total volume is volume of cylinder plus volume of cone. Volume of cylinder is pi radius squared times the height, which is 14. Okay, plus volume of the cone is pi r squared. Sorry, why am I doing r? 7 squared. And what's the height of this is 12. There we go. Don't forget to divide it by 3, please. And so if I do this, I'm just going to go to 22 here and check my key to make this a little bit faster. I get, if I do this part, I get 2155.13 ... plus, if you do this part, you get 615.75 ... Please don't round yet. If you add that up, you get 2770.88. Are we good there? That's the total volume. I'll try the surface area underneath here. What do I need for surface area? I need my slant height. Okay, pyramid and cones, anything that's slanted, you have to either find a slant or the height. Chances that they give you both are slim to none, okay? So let's draw this out. We have 7, 12. What is this? This is the hypotenuse, my slant height. That's the longest side, right? So you think of longest side, obviously I have to add, right? I have to add the squares of the legs. So 12 squared plus 7 squared. 144 and 49, 193. Watch what I'm going to do there. Don't round too soon, okay? So let's figure out what the square root of 193 is. Is that right? Let me check that. 12 plus 49. Oh, sorry. 12 squared plus 49. 193, yeah. Take the square root of that. What do you not like? There. 13.89 ... right? Don't round just yet. I'm going to highlight that one because it's hard. You usually miss it if you look through your notes, right? Let's figure out the surface area. TSA. We're going to do, how do you want to start? I'm going to start with the cone. Surface area, I'm going to go LSA of cone. Does that make sense why I go LSA of cone? Because the circle I don't want. Okay, plus surface area of cylinder. That means all of it. I'm doing the whole thing when I write it like this. But I don't want all of it. I need to take away the circle from it as well. So I'm just going to go minus a circle. Area, how about this? Otherwise you're going to be like, what? Minus 0? Just area of a circle. So technically we're taking away 2 circles. Okay, but I've already taken care of that by just going lateral surface area of the cone, meaning I don't even include that. So here we go. It's pi rs plus, this is a different one, 2 pi r squared plus 2 pi r h minus pi r squared. Why am I writing out the formula here and not otherwise? Sometimes I find it's just better to write out the formula. So it's pi r s, so the slant is 13.89 dot dot dot, plus, let's see if we could do some magic here. These are the same circles, right? The 2 pi r squared and the pi r squared here, we're talking about the same circles, right? Can I cancel one of these pi r squares with the 2 pi r squares here? You could. Maybe I'll just leave it. Because I don't want to cause any trouble today, okay? I'm just going to stick with my method here. 2 pi r h. This is the h of the cylinder, which you know is 14. Right? I put that in square brackets, kind of just to say that this chunk is right here with the substitutions minus pi radius squared. And you can tell now that pi r squared is the same as this pi r squared. So you could technically just get rid of this 2 here, cross that off, and cross this whole expression off. Okay, if you calculate all of this, how did I do it? Okay. Are we good so far, Philbert?
Yeah, it's because I was looking on my study sheet and I didn't have the surface area of the volume for
Okay, I did that yesterday. It wasn't on the original video. So pi times 7 times, oh, I'm going to go look at my height, slant height. There it is. It's 305. Plus, let's do the square bracket separately. 2 pi r squared, that's 49, right? Plus 2 pi times 7 times 14. That is 923.62 dot 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 minus 7 squared times pi. That's 153.93. Now that you have that all, just go that plus that minus the circle. That's 1,075.20. And we are in square feet. We're good? The struggle is real. Yeah, it's that time of the year. Do we need this one? How about I just write it out at least for you, like what I would do. This one for surface area, I would go surface area of the box. How do you want to go about it? I'm going to go plus. You've now created that hole. Oh, I made this one. This one I did make. Because I did the work, I'm going to actually show you whether you like it or not. I'm pretty sure I made this one. Oops. Almost dropped the whole thing. I thought at least. Oh yeah, here, this one. I just wanted to show you how the hole is created, right? So at first you just have a box, right? But then this, pretend like you're drilling a hole triangular like that. I can just group it all. No, wait, I gotta turn this one into a hole. And then I group it like that. And all of a sudden you have that hole in there, okay? You can make this transparent too, I think. You see? Transparent on. So there it is, right? That is your shape that you're thinking of. So box first, then we zoom into the sides here. There's 1, 2, 3 rectangles going in. And I have to subtract what? 2 triangles from the whole thing. Okay, so here we go. Surface area box plus 3 rectangles. Inside, how about this? The 3 inside rectangles minus 2 triangles. That would be my approach. And I'll give you the answers if you want to practice this. Total surface area is 492.21, and the volume is 433.23. By the way, how would you do the volume for this one? Volume of box minus volume of that shape that's inside. This one is probably worth doing. Actually, now that I think about it, I will do the volume. Total volume. Anybody do this already? Did anybody finish this one?
I did surface
Surface area? And did you get this?
area. Yes.
Okay. And volume? Well, this is why I want to do volume, because I didn't give you a formula for this one. It's not a basic shape that we have. So we will do volume of the box minus volume of triangular prism. Volume of box is fairly simple. Minus, what is the volume of this thing? How would you remember the definition of a volume? It's the area of, it's the area of the base times the height of this thing, okay? So the area of the base is a triangle, and then you stack it, and it's the height. It's the entire height of the box. So we're going to go area of triangle times height. Okay? And what is it's a 5 by 8 by 12, that's the height, minus, what is the area of just one of these triangles? It's a little tricky, okay? It says that it's an equilateral triangle, so it's 3 all around. So the area of this would be base times height, we need to know this height, divided by 2. So the problem is we don't have this small height here for this one triangle. So we're going to do Pythagorean theorem. This is the height we want. This is 3, and what's this here? Down here? 1.5. Yeah. Most of the time you can just do mental math on those. To find the height, let me zoom into that. Some of you are squinting already. It's a square root of 3 squared minus 1.5 squared. That gives you root of 6.75. Yikes, yikes. 598 dot dot dot. I'm going to highlight that one as well. Okay. We're going to put this in here. So 598 dot dot dot. I'm going to highlight that one as well. This is the area of just one triangle. So I'm going to copy that over here actually. 3 times 2.598 dot 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 divided by 2. All of that times the height. What is the overall height? Capital height. Capital H is 12, right? It's the entire height of this box. Let's put 12 here. Okay, so that's 12. So 5 times 8 times 12 is 480 minus this whole thing. It's going to be ugly, but we have it stored. That is 46.76 something. So that's 433.23. And we are in centimeters. Centimeters cubed. And I will highlight the height here one more time. This is lowercase h. Can we put a capital H here? That's like capital H. This is also capital H. That's like the big height for the entire 3D shape. Okay. I'm going to stop for a little bit because you guys are probably thinking,